Let's practice the trapezoidal rule and Simpson's rule. Our first example asks us to use the trapezoidal rule with n equal 5 to approximate the given integral. We're going to round our answer to 2 decimal places. So let's start by calculating the increment h, which is defined as b minus a over n. B represents the upper limit of integration, which is 3, and a is the lower limit, which is 1. We're going to be dividing by the given n value, which is 5. Overall, we've got 2 over 5, which is 0.4. So we're going to build a table of x and y values. The y values are going to be given by whatever function it is that we're trying to integrate. So in this case, it's the root of 1 plus 2x cubed. And let's start with our x values. Our x values begin at the lower limit of integration, which is 1, and they're going to be going up in increments of h. So we'll have 1, 1.4, 1.8, 2.2, 2.6, and then finally 3. Now to get the y values, we're going to be plugging the x values into this square root function, and we're going to keep our y values exact. So our first y value is going to be root 3. Second y value, if we plug 1.4 into the square root function, we're going to get root 6.488. And we're going to work our next y values out in a similar way just by plugging each x value into this square root function. Now the trapezoidal rule tells us that the integral is approximately h over 2 times the following sum. We're going to be summing up our y values. The first and last y values have coefficient 1, whereas the middle y values get coefficient 2. So let's plug into this formula. H was 0.4. We'll divide that by 2 and then multiply by the sum of the y values. We'll have root 3 plus 2 times root 6.488. And now I've written down the rest of the terms in that sum. So let's just make sure first and last y values got multiplied by 1. The middle y values got multiplied by 2. Plugging into our calculator, we get an answer of about 8.57. So the trapezoidal rule has allowed us to approximate that integral in the question as 8.57. For our second example, let's use Simpson's rule with an n value of 4 to approximate the given integral. This is the same integral as we had in the first example, and we'll round our answer to 2 decimal places. As before, the increment h is defined as b minus a over n. B is the upper limit of our integration, a is the lower limit, so that's going to be 3 minus 1, and we'll be dividing by the n value of 4. So overall, that gives us an h value of 0.5. Now we're going to make a table of x and y values, and the y values are going to come from whatever function it is that we're integrating. In this case, it's root 1 plus 2x cubed. Now our x values are going to start at the lower limit of integration, so that would be 1, and they're going to go up in steps of whatever our h value is. So we'll go up in steps of 0.5. So our x values will be 1, 1.5, 2, 2.5, and we'll go up as far as 3, which is our upper limit of integration. So we're going to take our x values, plug them into this expression for y. When we plug in x equal 1, we'll get a y value of root 3. And just like in our previous example, we want to keep these y values exact, so we don't want to turn that into a decimal expression. Plugging in the x value 1.5 into our square root function, we're going to get root 7.75. We'll work out our other y values in a similar way, just continuing to plug into that square root function. Now Simpson's rule tells us that the integral is approximately h over 3 times the following sum. We're going to be summing up our different y values, and we just need to pay attention to the coefficients. The first and last y values get coefficient 1, whereas the middle y values have coefficients that alternate 4, 2, 4, 2, etc. And Simpson's rule requires that n is even in order for this formula to work out properly, in order for the coefficients to alternate properly. So let's plug in here. H is equal to 0.5. We're going to divide that by 3, and then we'll sum up our y values with the correct coefficients. It's a good idea to check the coefficients here. So the first and last y values have coefficient 1. Middle coefficients alternate 4, 2, 4. So that's great, and we're going to plug the expression into our calculator and round off to 2 decimal places. So this works out to 8.54. If you remember from our first example, our approximation using the trapezoidal rule came out to about 8.57. So we've got good evidence here that both our approximations are reasonably valid.